Day 176 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. This time, day 175. Y'all, we're making some progress. In about 5 days, we're going to finish up the hash table portion of this channel, and we're going to move on to the top 150 interview questions, y'all. So get ready for that. We're about to finish up our month of hash table problems. We did a month of easy strings. We did a month of easy arrays, and our month of easy hash tables has about 5 more days, y'all. So get ready. We're about to move on and do the top interview questions, top 150 interview questions after this. But before we get started today, y'all, don't forget, bring a mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. And after you smash that like button, I'm calling all of my bankers. I repeat, excuse me, y'all, my bad. I'm calling all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we can run up this engagement and we can do our part in sharing the Swift content out with a broader audience, y'all. It's up to us as Swift community members to help the community to grow. And one way we can do that is to share this content with as many people as we could find that will watch it, y'all. So your support is appreciated for that. Now, let's get into the question. And today we have question number 1122, relative sort array. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well, because we're all here to learn. And if you don't understand the solution at the end of this video, then you probably didn't learn anything, and that is not what we want, y'all. So let's see what the question says. It says, given 2 arrays R1 and R2, the elements of R2 are distinct and the elements in R2 are also in R1. Sort the elements of R1 such that the relative ordering of items in R1 are the same as in R2. Elements that do not appear in R2 should be placed at the end of R1 in ascending order. So let's break that down and see what that means. We got 2 arrays. We have the input. Let's look at example 1. We have input R1. It's an array of integers 2, 3, 1, 3, 2, 4, 6, 7, 9, 2, 19. R2 is also an array of integers 2, 1, 4, 3, 9, and 6. The output is an array of integers 2, 2, 2, 1, 4, 3, 3, 9, 6, 7, and 19, y'all. So let's break that down and see how they got this output from this input, right? So it says right here that it says this is what it wants us to do. Sort the elements of R1 such that the relative ordering of items in R1 are the same in R2. And it lets us know right here that the elements of R2 are distinct, meaning R2 only has one of each number, where as you see in R1 there's duplicates, like there might be a 2 right here, there might be a 2 right here, a 2 right here, but the elements in R2 are distinct, meaning there's only one of each element. So, and all of the elements in R2 are also in R1. So all of these elements are also in R1. So what we're doing is we're sorting these elements in R1 in this order, right? So we're gonna do the 2's, boom. So because 2 comes first, there's 3 2's. There's 1 right here, there's 1 right here, and there's 1 right here. So we take those 3 2's and we put them right here. Then we're gonna do the 1's. So there's only 1 1, and that's right here. Then we're gonna do the 4's. There's only 1 4, and that's right here. Then we're going to do the 3's. There's 2 3's. There's 1 right here, and there's 1 right here. So we're going to put those 2 3's right here. Then we're going to do the 9's. There's only 1 9. Oh, excuse me. There's only 1 9 right here. So we're going to put it right here. Then we do the 6, and there's only 1 6 right here. We put it right here. Then it says if elements that do not appear in R2 should be placed at the end of R1 in ascending order. So 7 and 9 do not appear in R2, so that's why we put this 7 and 19. That's why we put this 7 right here and we put this 19 right here in ascending order, because 7 comes first before 19, and that's why the order is like that, and that's why this is the output for input in example 1. So let's look at example 2 since there's only one more example. It shouldn't take us that long to get through it. In example 2, we have our input is R1. It's an array of integers 28, 6, 22, 8, 44, 17. R2 is also an array of integers 22, 28, 8, and 6. The output is 22, 28, 8, and 6, 17, 44. And it's also an array of integers, right? So it was the same thing as before. We're going to sort these elements. We're going to sort these elements in this order. So the first thing we're going to do, we're going to get to 22 because 22 comes first in R2. So there's only one 22, so we're going to put it right here. Then we're going to go do 28. There's only one 28, so we're going to put it right here. Then we're going to go find the 8. There's only one 8, which is right here, so we're going to put it right here. Then we're going to go find the 6s. There's only one 6, so we're going to put it right here. Then we're going to find, 17 and 44 are not in this input, are not in R2, so we're going to put it at the end of the output in ascending order, which is why we put the 17 first and the 44 second, like so. So, let's see how we're going to code this, y'all. The fun part, the part we all know and love. Let's get into it. So the first thing we are going to do is we are going to declare, we're going to declare a variable called count. We're going to set that equal to R1 dot reduce. Open up the parentheses, we're going to say into. We're going to open up the code, we're going to say colon, and we're going to create a blank dictionary like this with the square bracket, colon, square bracket. And that is going to reduce R1 into a blank dictionary. Now you're probably wondering, where are the keys and the values going to come from to put in this blank dictionary? Because as y'all know, a dictionary is going to have two values, it's going to have two elements or two parts to it. There's going to be the keys and the values, and this is how we're going to do the keys and the values. So first thing we're going to do is we are going to open the brackets and we are going to say $0, $0. Open up the brackets and we're going to say, so first this right here is going to represent each dictionary that we're about to reduce R1 into. So this $0 represents each dictionary that we're about to create. Then we're going to open up the square brackets. We're going to come inside of the square brackets. We're going to say $1, comma, default 0. So for each, so this $1 is going to represent each element in R1 that we're going to put into the dictionary, and this default 0 is going to keep count of each element that we see. So we're going to come outside of, we're going to come outside of the square brackets and we're going to say plus equals 1. So each time that the dictionary sees one of the elements, it's going to add 1 to the count. It's going to increment this default count by 1. Then we're going to come outside of that. We're going to say comma res equals an array of integers. So we're going to create another variable called res, and that's going to be equal to an array of integers, and we're just going to initialize it with the parentheses like that. Then we're going to come down here and we're going to say for n R2, or no, that might get confusing. We'll say for I in R2. We're going to open up the brackets and we're going to say res, which is what we just created up here, the variable we created up here. We're going to say res plus equals array, open up the parentheses, repeating, colon, n, comma, count, colon, count, square brackets, n inside. Put the exclamation mark outside of the square brackets because it's optional. But what this is going to do, we just we just initialized res up here by saying it's going to be an array of integers. Right here, we're going to create the array of integers, and it is going to be repeating ends. So, or excuse me, this should be I. Should be repeating I, but it's the repeating numbers. The N was for numbers, but we're just going to keep I just because that's what people are used to. So the whatever I is, the res array is going to create repeating I's that up to that count, that or however many counts of where I is, if that makes any sense. But we're going to create an array of the I's, and we're going to keep count of each I that we see, right? Then we're going to come down here and we are going to say count square brackets n equals nil. So we're going to start, excuse me, I keep saying, and we're going to clear it all out, and we're going to do it again for the next element in R2. Then we're going to come down here and we are going to say for parentheses key comma value, excuse me, value, we are going to say n. So this is going to be the key in this dictionary that we created up here, and this is going to be the value of this dictionary that we created up here. So we're going to say for parentheses key comma value n count dot sorted, open up the parentheses, by colon, open up the brackets, $0 dot key. So for each key is less than $1 dot key. So for each key that is less than the next key, each next key, excuse me, y'all. Then we're going to come outside of that. We're going to open up the brackets. We're going to say res plus equals array. Open up the parentheses. Repeating colon key comma count colon value. Then we're going to come outside of that for loop, and we are going to say return res. So let's run this, see how it runs. Hopefully it runs on the first try, but you never know. Let's see. Ooh, look at that, y'all. So let's submit it. See what happens after we submit it. Make sure it stays accepted. Oh, y'all already know I love those numbers. 0 milliseconds beats 100% of users with Swift, y'all. That's faster than a Bugatti riding past all the brokies down the Autobahn, y'all. That's what I like to see. That's what I like to see, y'all. And I also like to see y'all tomorrow for another day, another LeetCode problem. See y'all then.